All right, guys, I'm going to go over 4 basic rules for probability. But before I do, let me explain the difference between an independent event and a dependent event. All right, so this is very simple to understand. Independent events are 2 events that are completely isolated from one another. For example, flipping a coin, right? If I flip a coin, there's a 50% chance it's going to land on heads, right? If I flip it again, that second flip has nothing to do with the first time that I flipped it, all right? Thinking that you're going to get tails just because you got heads the first time is a fallacy. That is not correct. It has nothing to do with the previous event. Okay, so those are 2 independent events. Now, a dependent event is that one probability change. That the probability will change the next time that you do an event. For example, if I am looking for the ace of spades in a deck of cards, and I were to, I would think I have a 1 out of 52 chance that I'm going to draw the ace of spades in my first try, right? That's in my first try. If I were to take that card out and I were to try this again because I didn't get the ace of spades, my chance of getting the ace of spades is now higher. It's not 1 in 52 anymore because I don't have 52 cards. I've only got 51. So that's 1 out of 51. So that's an example of a dependent event. So it's important that in these problems, you are careful with whether or not your events are independent or possibly dependent. All right, so there's 4 main rules. All right, your independent rules. The probability of A and B is going to be the product of the 2 probabilities. For example, the probability of, if I'm going to flip a coin twice, the probability of getting heads and then getting tails, that's going to be, well, 50% times 50%, or 1/2 times 1/2, which is 1/4. All right, so that's a simple product. And then there's this rule, which I think is kind of redundant. The probability of A given B. In other words, for example, the probability of getting heads given that you got tails the last time. So again, if this is independent, then it does not matter that B happened. So the probability of A given B is simply the probability of A. If I switch those letters around, the probability of B given A is the probability of B. So that's simple to understand. All right. Then we've got some more general rules. All right. Here's for the given information that we've been looking at. Probability of A given B in general is the ratio of the probability of A and B divided by the probability of B. All right. And then for my OR statements, the probability of A or B is going to be a combination of things. It's going to be the probability of A plus the probability of B minus the probability of A and B. So you can kind of think of this as a formula for OR and for AND. Okay, so that's how these formulas work. I've got 4 examples right here in your notes. I'm not going to go over every single one of them in this video. Read through them, and basically here's my best advice. Look to see whether or not the events are independent of one another. All right, if they are, you've got 2 formulas at the beginning. And if it does not specify independent, then you've got 2 other formulas. Simple as that. So for example, right here I see given that events A and B are independent. Right, that's a red flag. Okay, and then it says probability of B given A. So the probability of B given A is just going to be the probability of B. All right, because they're independent. All right, here in my second problem, I see probability of A, probability of B, probability of A or B, and I want to find probability of A and B. As long as you write your formulas down, what you want to look for, well, you've only got 2 possibilities because they're not independent, right? Is you want to see which formula utilizes all of this criteria. So right here, my summation formula, right here, combining these events is what works. So probability of A or B equals probability of A plus probability of B minus the probability of A and B. And all I'm going to do is I'm going to substitute probabilities into the right places, and I'm going to end up subtracting to find the probability of A and B. All right, my third, and this final example, I thought I had 4. It looks like I have 3. No, I do have 4. All right, and in my final example, I've got probability that these events are independent. So once again, I'm looking at my first couple of formulas. Right, it says probability of A is 0.71, A and B 0.142. Find the probability of B. So I'm simply going to use the formula that utilizes those 3 expressions, which is my product formula. By quickly dividing, I can find that probability is 0.2. So it's all about finding the correct formula. Read the problem carefully, and you're going to make it.